With the global population reaching 7.7 billion as of 2019, sustainable farming is taking center stage in the agriculture technologies industry. More focus has been placed by governmental and international bodies to achieve sustainable intensification in agriculture. Creating more sustainable farming practices increasingly requires adopting new technologies that help with crop management, pest control, quality control, and integrated disease management. These new technologies are important steps to allow current and future generations of farmers to grow without compromising the needs of the earth. Here we explore just 10 of these emerging tools that can help today's farmers achieve precision and increase productivity. Number 1. Laser Scarecrows. Since the dawn of farming, the battle between farmers and birds has been a perpetual struggle. Recently, a researcher from the University of Rhode Island has invented a new deterrent to keep these birds away. The Laser Scarecrow projects green laser lighting not visible by humans in the sun. They are effective due to birds' sensitivity to the color green. The automated laser darts across fields up to 600 feet and effectively startle birds enough to prevent them from destroying any crop. They are also less environmentally destructive and less labor-intensive compared to the use of netting. There have been different variations of the laser technology, some of which come solar-powered, and with an auto-targeting system on birds. The technology has also been adopted by pest control companies who claim the device can prevent up to 90% of crop losses. Number 2. Bee vectoring. An exciting new development in disease control management is bee vectoring. A company in Canada has proven bee vectoring to be effective in integrated disease management and pest control. The technology uses a naturally occurring fungus called BVTCR7, or vectorite, that helps protect crops from a variety of diseases. The vectorite solution is placed inside a hive of commercially raised bees, and the bees collect the solution whenever they exit the hive. The solution is then distributed by the bees to the surrounding crops and fields. Besides increased disease resistance, the technology also enhances plant growth, and naturally prolongs the shelf life of crops. All of these benefits come without the use of chemical pesticides. The innovation is groundbreaking as it integrates nature with agricultural industry systems. Number 3. Harvest Quality Vision, HQV. The Harvest Quality Vision is a new technology that simplifies the harvesting process of fruits and vegetables by eliminating the need for manual inspections. Released this year, HQV uses computerized scanners to capture and determine the quality and quantity of crops. The huge volume of apples and other fruit harvested at one time means that most fruit is not being graded before it is put into storage. Using a camera to grade produce means better sorting and management of the produce without damage caused by human or machine handling. The software creates alerts whenever there are deviations, such as diseases, defects, and quantity shortages, so that growers can correct their course of actions early in the harvesting process. HQV helps farmers produce more consistent crops of higher quality, which increases the farm's revenue. Number 4. Product testing in field or on site. The farming practices of some crops, such as cannabis and hemp, are highly regulated and require strict lab testing and reporting. This creates a demand for innovations in in-field product testing technologies that can lower the cost, hassle, and wait time to get lab results. Light Lab is one of these inventions. The portable and lightweight equipment can accurately test for the cannabinoid profile of such crops outside of the lab. Sampling and tests can now be carried out in the field, or at processing centers, saving growers time and simplifying the production process. Another device that carries out a similar function on grain crops is the Minichromosome 2500. The equipment can capture accurate readings to render benefits such as an expanded grain temperature range and faster analysis time. This results in an elimination of shrink charges and dockage fees, as well as better control over the drying process of crops. Number 5. Crop and soil monitoring and management. Precision farming involves a lot of data collection and management. It can be tedious and prone to human error. FarmBeats has discovered a technology that works in real time, which feeds it into a cloud-based model to render a detailed picture of how the farm is performing. Tools such as SGS can also help you to strategize a nutrient delivery plan that can increase crop yields, enhance environmental protection, and fine-tune precision. This is done through precise sampling, mapping, and testing with the help of GPS and GIS. Growers can now be in full control in understanding the soil's macro and micronutrients, as well as its salinity, carbon content, and other factors, so as to achieve optimal conditions when planting. Number 6. Automated farm equipment. Automated farming equipment such as a self-driven tractor or seeder solves the problem of both time constraints and labor shortages. Machines like these can work round the clock tirelessly to bring higher yields in a shorter time. They are perfect for orchard management, as they allow farmers to work on more important things, such as strategizing an improvement in quality for their crops instead of focusing on menial and manual labor. Number 7. RFID. Radio frequency identification is a technology that utilizes radio waves to capture information tagged to an object. They have similar functions as a barcode, but work more efficiently and comprehensively in a farm setting, as they can be read invisibly and from several feet away in the dirt. Crop Tracker has harnessed the technology of RFID for the use of the harvest, storage, and packing of crops. It reduces data errors through automation, and allows for enhanced traceability and swift recall management when the need arises. The technology eliminates the risk of costly human error during organization processes. With RFID, customers will be able to know the origins of the product they have on hand, which will lead to more customer loyalty and trust. Number 8. Real-time Kinematic. Real-time Kinematic, RTK, is an emerging technology used to enhance the accuracy of existing GPS signals. The technique eliminates the majority of standard GPS errors to centimeter-level accuracy. RTK improves GPS, or satellite tracking with stationary receivers in the field, to predict more accurately the yields and expenses of farming. This technology is being applied to land surveying mostly right now, with the goal of aligning the best plant density and treatment plans to the land being planted. Number 9. Vertical farming. With the urbanization and industrial development of countries comes a loss of arable lands for farming. A third of arable land has already been lost over the last 40 years, and vertical farming might be the salvaging solution. With the technique of growing crops in vertically stacked or inclined surfaces that can be integrated into other structures or buildings, vertical farming can produce more crops with less space. This can be the answer to meeting the increasing food demands of an ever-growing population, especially in cities. Farmers can also take advantage of greenhouse settings that can be integrated into vertical farming. This means the production of year-round seasonal crops without any effects from the climate. Number 10. Minichromosome Technology. Genetic engineers have harnessed the application of minichromosome technology to enhance the genetic traits of a plant. Although containing only small amounts of genetic material, the minichromosome can be manipulated with the use of genetic engineering to achieve biofortification, the enhancement or supplementation of the crop's nutritional content. It can also improve crop resistance with new traits such as drought tolerance. Because of the minimal amounts of genetic material minichromosomes contain, they make effective vectors to express foreign genes, without interference with the host's natural development and growth. The technology has not been fully explored, and has great potential for broad applications in agriculture. Because of the utilization of the plant's original chromosomes, there is a less negative connotation labeled by consumers, compared to other genetically modified foods. The rise of technology, coupled with the need for higher productivity, has opened up a wealth of new understanding with the collection of accurate data. The investment in agriculture technology has seen accelerated growth of more than 40% just last year. This adds up to approximately around $17 billion. Innovations can now provide farmers better reign over crop quality control, pest management, and even the optimization of their existing practices to achieve higher revenue. Farmers can now leave less to speculation with the new understanding and accurate forecasts of their harvests. Thanks for watching. Make sure to subscribe to this channel.